Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 14E, exercise Miscellaneous Sums. 14E, miscellaneous exercise, cancellations 1, 2, 3, 4, 6, 8, 11, 12, 13, 15, 16, 17, 18, 22, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 35, 34. No, 34 is there. Even 35 is there. 36 is cancelled. 38, 39, 40, 41. All these sums are there in the syllabus, but they've been cancelled because they are of the same type of sums which we have studied in exercises 14A to 14D. So to reduce your homework, I'm cancelling this from your homework. But if you have time, please solve them as well. It will be an extra practice and you'll be better at this chapter. Only the 11th sum is something I've cancelled because it is very complicated and won't come in exams. So out of syllabus. Let's start with the 5th sum. A straight line passes through the points P and Q. It intersects the coordinate axes at A and B. So immediately you should be able to say that A's coordinates will be x comma 0 and B's coordinates will be 0 comma y because they are lying on x and y axis respectively. M is the midpoint of AB. Find the equation of the line. That's straightforward. I've got 2 points P and Q, so I can use a 2-point form to find the equation. What is the first step we do in such a sum? Find the slope. We find the slope and then we use any one of the points to use the slope point form and frame the equation. Always give the heading of the line you are discussing about. PQ, we find the slope using the formula, and we take any one point, either P or Q would do. This is the point slope form, and substitute the values and you get the final equation, x plus y is equal to 3. Roman number 2, find the coordinates of A and B, which are lying on the x and y axis respectively. Since both these points lie on this equation, that is lie on PQ as well, they will satisfy this equation. So if A lies on the line, so I can substitute y as 0 and get the answer of x. So A's coordinates are 3, 0. Similarly, even B should lie on the line. Look at the diagram in the textbook. B lies on PQ as well, not just the y-axis. So even B will satisfy the equation. So substitute x as 0, get the value of y, so you get B's coordinates as well. Next, in the question it was mentioned that M is the midpoint of AB. Now that we have the coordinates of A and B, you can use the midpoint formula to get the coordinates of M, which was asked. So this is the final answer. Next, let's do question 9. A straight line passes through point 3, 2, and the portion of this line is intercepted between the positive axes, that is the x and y. It is bisected at this point. Find the equation of the line. Now the first step is to draw a diagram. If you get that right, the sum will be easy. Try it. Pause the video and try to draw the diagram. Does it look like this? Read the question again and check if this is the appropriate diagram. I'm assuming the point of intersections to be A and B respectively. A will be x, 0 obviously. B will be 0, y. We do this often in many sums. P is the given point, 3, 2. And they are saying that P is actually the midpoint of A and B, of AB rather. So we can use a midpoint formula to find P. This is the midpoint formula using points A and B. These should be the coordinates of P. But the coordinates of P are already given. So by comparing, I can get the value of x as 6 and of y as 4. So this way I got the values of A and B's coordinates. Now equation of the line. Good news is we have 3 points, A, B and B. We just need 2 points to find the equation. Step 1, get the slope. AB line. So get the slope. I'm using A and B to find the slope. You could have used anything. And you have to take any 1 point for the equation. I'm going to take P for forming the equation. You could take any point which is lying on that line. So this is the format. Substitute the value of M, X1 and Y1 and remove the LCM, open the brackets, rearrange the terms, and you get this as the final answer as the equation for AB. Make sure you give the heading AB. Next, let's do the 19th sum. A, B and C are the vertices of a triangle and P is the midpoint of AB and Q is the midpoint of AC. Prove that PQ is parallel to BC. Now using geometry, we could have used various theorems, but here we have to use coordinate geometry. It's specified here. So how do we prove any two lines parallel in coordinate geometry? Well, we find the slope of PQ and then of BC, and if the slopes are equal, that means they are parallel to each other. But how do I get the coordinates of P and Q? Using the midpoint formula. P is a midpoint of AB, so find the coordinates of P. Q is a midpoint of AC, find the coordinates of Q, and then we can find the slope of PQ, find the slope of BC. Slopes are equal, hence they are parallel, and that becomes a trapezium, which is also asked in the question. Now the 23rd sum. There are two lines AB and CD and their equations are given. We've been asked to find their inclination and also the angle theta between them. Well, from the equation we can find the slope, and from the slope we can find the inclination, that is theta. So the first equation, y is equal to mx plus c, it's already in that format, so m is the slope, and if m is 1, then definitely the angle, that is the inclination, is 45 degrees. Note that this theta is not the theta shown in the diagram, so you may want to use the sentence inclination of AB is 45 degrees. Similarly, CD's equation is given. It's already in the format y is equal to mx plus c. So m is root 3. That means the inclination is 60 degrees. Now, if this is 45 degrees and this is 60 degrees and they've asked to find this theta, that is the angle between the two lines, we'll have to use geometry. In triangle RPQ, yeah, draw the diagram and give all these labelings. 60 is an exterior angle for this triangle, and the exterior angle property states that the exterior angle is equal to the sum of the remote interior angles, that is 60 is equal to 45 plus theta. So that's how we get the value of theta as 15 degrees. A longer method would be using linear pair, find this angle, which would be 120 degrees, and then angle sum property of a triangle total is 180. You can find theta. Next, let's do sum number 35. A line through point P meets the x-axis at A and y-axis. It will be again the same assumptions we have to do. We have to draw the diagram, and A will be x comma 0 and B will be 0 comma y, and P is somewhere between them. But it's not the midpoint here. This time they're not saying that it's a midpoint. Rather, they are saying that BP is twice of AP. That means BP ratio PA is equal to 2:1. This ratio will be useful because we are going to use section formula to find the coordinates of P. This is the section formula. So using the coordinates of A and B, I am getting the answer of P's coordinates as 2x upon 3 and y upon 3. But the coordinates of P are already given as 4 comma 3. So by comparing, I can get the value of x as 6 and get the value of y as 9. So now we have the coordinates of A and P. Next, they want us to find the equation of AB. But that's easy. We've got 3 points, in fact. So first we'll find the slope using any 2 points. Then using the slope and any one of the points, and in this case I took the point A for reference, substitute the values in the equation, solve and get the final answer of the equation. Finally, the 37th sum. Find the equation of the line through the points A and B. Oh, that's easy. And then show that C is a collinear with them. That is, it lies on line AB. Well, first of all, for AB, find the slope because 2 points are given. Use any one point to use the slope point formula to frame the equation, and I get it as x plus y is equal to 2. Now, how do I prove that C is collinear with A and B? That is, all three should lie on the same straight line. Well, what I can do one is, what if I find the slope of BC? And if the slope of BC is exactly equal to the slope of AB, that means they are parallel to each other. Also, since both of them have a common point B, that means not only is AB and BC parallel, but they are the one and the same line, ABC. And hence it will be proved that ABC are collinear. But I'm going to use another approach here. What I'll do is, I'll try to prove that C, the coordinates of C, satisfy the equation. And if any point's coordinates satisfy the equation, it means it lies on that line. And if it lies on that line, it means that A, B, C are collinear. By the way, we can't really judge right now if B is between AC or C is between AB, and that doesn't really matter. We only have to prove that they are in the same straight line. So, substituting this in the LHS, x plus y, I am getting it equal to the RHS. That means it lies on AB. That means they are indeed collinear. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.